Okay, so we're going to look at some things to do with correlation, and we looked a little bit at this before. So we've been looking at our scatter graphs, and a while back we discovered three different things about our scatter graphs, and the relationship or the trend between two variables on our scatter graph can be measured in three ways. So we talked about this before. If you can't remember, don't worry. So we've got something called the form. And the form is to do with, if I draw up an example, maybe that will help you see what I mean by form. I'll do maybe a couple of examples. 1, 2, 3. So let's imagine our scatter graph was like this. Let's imagine it could look like this. And let's imagine it looks like this. You can all see this okay? And these are my variables x and y. So this one was form. Who can remember what we call this one? And it's to do with the kind of where these points are all laid out. And it's to do with what we've been working on with our straight lines. And that's something else which we'll talk about. There's Enrique. It begins with L, I, N. Okay, so this one was linear, linear form. And it's to do that it looks like a, what type of line? Yeah, it looks like a straight line. Whereas these other two that I've drawn, do they look like straight lines? No, they don't. They look more like curves. So these ones are non-linear. Hi, Enrique, are you there? Okay, good. So that was form. And the second thing that we looked at was to do with direction. And some of you just mentioned this already. So the direction was to do with if it is, if our variables are increasing in a, so what kind of direction is this first one in? And what kind of direction is the second one that I'm drawing in? First one is in a, what kind of direction would you guess? Some of you have mentioned the word already. Yeah, it's positive, okay? It's in a positive direction. As x goes up, y is going up. It's going up in a positive direction. So if that one's positive, this one is going downwards, it's sloping down. We could say this one is in a negative direction. Okay, so that was direction. And of course you could have, okay, well, we'll leave that one for a second. And then the third type of thing, so we've got form, we've got direction, and the third thing we looked at was the strength. So the strength. And I'll do up a couple of examples of this. So strength was to do with, let's see, we could have medium strength, we could have we could have weak strength, moderate strength, or strong strength. I'll draw up different ones. So these are all positive. But which one, if I number them, 1, 2, 3, which one would you say is the strong strength? 1, 2, or 3? 2, because yeah, they all look like in a straight line. Okay, so this is strong strength. Somebody apart from Oscar, because he's answered quite a lot so far. Thank you, Oscar, though. Which one would you say is a weak strength? Which ones are the least like a straight line? Yep, 1. And then the one in the middle is medium strength. Okay, good. Do you all remember that vaguely? I will take your silence as yes, you do. Okay, so what we're going to look at today is, I put the title up, and it's called Correlation. So correlation measures the strength and direction between two variables. Okay, so correlation looks at both strength and direction. And what I'm going to do is I'm going to pull up the textbook and have a look at this. So here we've got different ideas of correlation. We've got these little tabs. Bigger. So we've got weak negative correlation. We've got strong positive correlation, perfect positive correlation, strong negative correlation, perfect negative correlation, weak positive correlation, and no correlation. If it's negative, the dots are they gonna go upwards or downwards? Yeah, they're gonna go downwards. If it's positive, the dots are gonna go upwards, right? So looking at these, let's pick. Let's look at the first one. Okay, weak negative correlation. Which one of these do you think would be a weak negative correlation? Okay, D possibly. If it's negative though, the dots are the dots are going to have to go down. So it could be E, it could be F, it could be G. Okay. Now which one of these is the strongest one? G is, yeah, because they all look like in a straight line. We want the weakest one. So which one would be the weakest? I think Ryan said it. Yeah, E. Good. So this one would be E. Good. Okay, what about this strong positive correlation? Which one of these do you think would be a strong positive? So the dots are going to have to go up, and they're going to have to be quite close together. Now be careful because we've got this other one called perfect positive correlation. So do you want to rethink, Enrique, for strong positive? Okay, yeah, it would have to be B because that would be strong. It's positive. And perfect means that they are in a completely straight line, okay? What I want you to do in the chat, the group chat, is to type in which letter you think would be strong negative correlation. Type it in the private part. So everybody type in which letter would be strong negative correlation. Okay, good. Yeah. Okay, good. He hasn't put in. Kai, can you stick in? Oscar. Okay, let's have a look. So you're all on absolutely the 100% right track. We want strong negative, so it has to be one of these two, F or G. Now, one of them is strong, one of them is perfect. So the strong one is going to be F, because the perfect one is in a perfect straight line. That one would be G. Okay? Is that okay with everyone? All right. Okay, so strong, it's not completely in a 100% straight line, but perfect is in a completely straight line. What about weak positive correlation? Type in for me which one would be a weak positive correlation. There's only a couple left to pick from. This one's already, now we want weak positive, so remember if it's positive, the dots have to go up. Okay, good. So positive, it can't be G because that's going downwards. It can't be F because it's going down. It can't be E because it's going down. Positive means it's, oh, you misheard, okay. It has to be C because it's weak, they're kind of spaced out, and it's going in an upward direction. And then that means that no correlation, this is the last one, so that obviously has to be D because they're all spaced out. Now we can assign numbers to our correlation, okay? Now let's see which one would be easiest. If it's got no correlation at all, which number do you think would best represent that? If it's got no correlation at all. Yeah, you can just say it, yeah. D, yeah, because it's just completely random. Now, this has got no correlation, so we would say that this one, D, would be good for that because it's got zero correlation. What about perfect strong? Which one do you think that would be if this is perfect positive? Sorry. Which number do you think would best represent perfect positive? Which one of these numbers? Yeah, one seems like a good idea because it's positive, and it's the biggest number. Well, if that is one, then what do you think? What do you think B would be? What number? Now this is also positive, but it's not as perfect as this one. It's not as perfect as A. Yeah, 0.8. That seems good. Peter, can you tell me what you think C might be? What number C might be? It's not as strong as 0.8, but it's still positive. So which one of these numbers do you think would correspond to each of these graphs? So we're looking at C at the minute. We said 1. We said 1 is perfect positive. It's in a perfect straight line and it's positive. B is strong positive. Okay, it's strong, so it's 0.8 and it's still positive. Which one of these numbers do you think C would be? 0.3, that makes sense because it's positive, but it's not as strong as these other two. We said this one would be 0. Enrique, could you tell me what E do you think would be? No, it's negative now. Yep. Now negative 0. Now which one of these is the strongest one? G is perfect, so G would actually be negative. Well, F is strong, G is perfect. So if G is perfect, G would be negative 1. F would be negative 0.8. and that means E would be negative 0.3. So we can see the kind of range of values that we can get from these. Okay, let me just copy that. And I want to get rid of that. So we'll kind of formalize this in a little note. Get rid of that. Move this. Put that in. Okay, so we're going to write down. So correlations take values from -1 to +1. -1 means that it's got a perfect negative correlation. So that means it's sloping downwards perfectly. A value of 0 means it's got no correlation. It's just all randomly spaced out. And a value of +1 means it's got a perfect positive correlation. Okay, and then we've got everything in between. Okay, so the closer it gets to 1, the more perfect it is, positively. The closer it gets to -1, the more perfect it is in a negative direction. And the closer it gets to 0 means there is no correlation at all. So I just want to go and have a look. So this is just like a little scale of it. I'll also take a picture of this. So this shows us on a picture 0, no correlation, and the closer we move out to 1, it gets stronger and stronger and stronger. So it becomes positive, perfect positive at 1. The closer we move away from 0 in a negative direction, the stronger it gets in a negative direction. Is that okay so far? Maybe, maybe not. Okay. So I'm going to give you a few questions. Let's have a look at some of these. First off, describe each graph as having a positive correlation, a negative correlation, or no correlation. For those with a correlation, state whether the correlation is strong, moderate, or weak. So looking at these, what do we think for the first one? Let's annotate. Do we think there is a correlation here? If it is it strong, positive, or is there no correlation? What do you think, Ryan? Does it look like it's going up or down? Slightly, yeah. Yeah, I would say not really. It's not as obvious as the rest, so for the first one, yeah, I would say there is no correlation. What about B? Tyler, what do you think for B? Is there a correlation here? What do you think? Is it positive or negative then? Yeah, it looks negative. It looks like it's sloping downwards. And we have to then say, is it strong, moderate, or weak? Yeah, I would probably say it is weak. Good. What about this one, Enrique? What about C? Is there a correlation first off? Is it positive or negative? Yep. Is it strong, moderate, or weak? Yeah. I would say it's maybe. See, this is one of the things you can. It's quite subjective. I think it would probably be strong because they look like they're all very, very, very close together. Um, so I'd maybe go with strong, but yeah, you could be. It's quite subjective. What about this one, Peter? Yeah, I would say that's weak. Positive, good. And what about this one, Kai? Kind of looks. Is there a correlation? Yeah, it's a little bit. It's quite. Is it positive or negative first? It's positive. Would you say it's moderate, weak, or strong? Moderate. Yeah. See again. It's kind of as weak as this one, really. This one's quite weak. I would say this one's quite weak as well, actually. What about this one, Oscar? F. Um, yeah, I'd say moderate negative, maybe even strong negative. Um, so you get the idea, yes? We're kind of looking at these and we're seeing um, what the correlation is. And the good thing is when we do these on the calculator will work it out for us. So if I go on to clear all drawings, and let's get rid of this, and if I skip to page 232, so we're going to have a look at this. Now I can enter this into Desmos. Let me see if I can just quickly do it. Here's Desmos, and I need to put it into a table. So I've got 1, 2, 3, 4, 5, 6, 7, 20, 240, 950, 1500, 2200, 2600, 3500. Okay, so what I've done is I've just put in the data from this table, okay, and this is to do with the age of children and the expressive vocab that they know. So it's the number of words that they know. So when they're 1 year old, they know 20 words. When they're 2 years old, they know 240. When they're 7 years old, they know up to 3,500. So do you think it's going to be positive or negative, this one, when I draw it? Yeah, it's going to be positive. That makes sense because the older you get, the more words you know. Okay, so I've put it in, and let's have a look. I need to change my scale. We will go on the x-axis from 0 to 10. That seems fine. We can go up in ones. We'll go on the x-axis from 0 to 3,800, let's say. All right, so Ryan, you said positive. That looks fairly positive to me. Okay, it's going up in a positive direction. Would you say it's a strong correlation or weak? Yeah, well, they're quite spread out, but are they in a straight line? Yeah, they're in fairly well in a straight line, which is good. So I'd maybe yeah, I'd say maybe moderate strong, perhaps. Draw my line of best fit. So I can do this. So I want y1. So this is what we did last time. X1. And then plus C. So there's my line of best fit. And I can see from my line of best fit what I can actually read off what the line of best fit is. Annotate again. So my line is y equals, the value of m is 500. So 586x, and then take away my value of c here, so negative 771. So that's my line. Okay, that shows the trend. And this r value is the important one. It says r is equal to 0.9935. And what is that very close to? 0.99. What is that very close to? What value? Yeah, 1. Okay. And this is represents our correlation. It's called the correlation coefficient. So just like the way we were talking about whether it's 1 or -1 or 0, it tells us how strong the data is, how strongly related the data is. So this is very, very close to 1. So this is telling us that there's a very strong correlation here. Okay, this is very strong. So that means that there's a high correlation or a high trend between the older you are and the more words you know. Okay, so it's really good that sorry, I can't speak. The computer actually will work it out for you, and this is the value that we need. Is that okay so far? Yeah? No? Okay. Right. What we're going to do is I'm going to leave it there for the second, and we'll finish up a bit early, and so you can get ready for your next class. Let me just stop